In this chapter, we're going to build on concepts of temperature, internal energy, kinetic theory, and make it a little bit more practical. Talk about the operation of refrigerators, air conditioners, engines, heat pumps, etc. Lots of practical information and fascinating fundamental information as well. So thermodynamics is the branch of physics built upon laws obeyed by heat and work. Heat and work are both measured in joules. They're forms of energy. And the other element that those two will relate to is the internal energy, also measured in joules. So to set the basis, we need to make a few definitions. The system is, we use the word system like we did in previous chapters. You draw a dotted line around the objects of interest. The surroundings are everything else in the environment around those objects. The walls are the separation between the system and the surroundings. So for example, in a hot air balloon, the system is the hot air inside the balloon. Usually system in this chapter will mean a gas. And in this case, it does also. The hot air in the balloon. The surroundings are the cooler air outside and everything else outside of the hot air balloon. And the walls are the separation between the system and the surroundings. That would be the skin, or the fabric of the balloon. Two different kinds of walls we'll talk about. Diathermal walls are walls that permit heat flow. And I would imagine that the hot air balloon would have diathermal walls. There would be some heat flow from the inside to the outside of the balloon. But if you were to replace that thin fabric of the balloon with a nice thick layer of insulation, then you could approach adiabatic walls, which are walls that do not permit any heat flow. The state of the system are the values of the system, and remember the system is the gas, the hot air inside of the balloon, for the pressure, volume, and temperature and mass.